Hi, Yoram Solomon here again. Just yesterday, I attended an NSA, National Speakers Association, North Texas chapter monthly meeting where the speakers all of a sudden just disappeared. And the reason they disappeared, and they did come back, was because they had power outage. It happened twice during their presentation. This can happen to you too. This can happen to me. So I'm going to share with you what I do to prevent this from happening. Delivering a keynote or a breakout session or a workshop remotely through Zoom or any other software with all the technology around can be stressful. There is a higher dependency on the technology working well, and some of the things are outside of your control. So this is what I'm trying to address here. Now, keep in mind, I do have background in technology, many years in technology, so I feel more comfortable with some of the things that I'm going to describe. If you don't feel comfortable, ask for advice. At least you're going to know what to work with. So with that, I'm going to disappear, and as I disappear, I'm going to show you the content. So first of all, what if the power did go out? The first question you have to ask yourself is, what kind of equipment must stay running? Now, I know that you're thinking your laptop, maybe the lights, the microphone, the camera definitely has to remain running. All of those things have to remain running. Do not forget the modem and the router. It's not going to do any good if you have your computer running and your camera running and microphone and even the lights, but you have no connection to the internet, not because the internet is not working, it's just because your modem is powered by the same power that's running your home. The second question you need to ask yourself is, how long does it have to stay running? Power outages are typically short, maybe a minute or two or five. So maybe 5 minutes or 10 minutes is enough for you. Maybe you want to feel a lot more comfortable if your typical keynote is 30, 45 minutes. So you want it to stay on for an hour. And maybe you want to make sure that it stays on for a full day because you may be doing a full day workshop. That's a question that only you can answer. So first, what equipment must stay running? Don't forget the modem and router. And two, how long must it stay running? So this is kind of a diagram of what a very simple installation would look like. This is what I call your payload. It has your computer, your microphone, your camera, your lights. And the first thing that you would want to put here is a UPS. It's called an uninterruptible power supply, or UPS. And this is something that gets power from the power grid. And it has a local battery. It keeps charging that battery, and when the power from the power grid goes away, it generates the same amount of power. So typically it would just bypass it, give power to all of your equipment, and when power goes out, this would kick in using the internal battery, discharging the internal battery to generate the same 110 volts or 240 volts, depending on where you are, to keep things running. The thing that I said before is, keep in mind that if you don't have your modem that connects you to the internet, and that's typically provided by your service provider, Spectrum or Frontier or AT&T or anybody else, and even your Wi-Fi router, whether you connect to it wirelessly or you can even connect to it wired through a wire, if those things don't have power because they get their power before the UPS gets its, then you don't have a connection to the internet. One of the ways around it is if you want to keep your cell phone as a hotspot. And so your cell phone is now your backup internet. It connects to the internet wirelessly through your service provider. Most likely, even if the power went out to your house, that link is still there. You still can get internet on your cell phone. And in this case, you want to make sure that your cell phone is being charged all the time and the charger is run by the same UPS. So if the main power went out, your modem may have gone, your Wi-Fi router may have gone, but your charger and your cell phone is still up, and so you're connected to it through Wi-Fi. There typically is no way to connect to your cell phone wired through a wire to get internet through it. The next step is to actually just put a UPS to power your modem and Wi-Fi router. So I put two UPSs here simply because typically those are in different rooms in the house, and what you don't want to run is a power cable from one UPS just to power the modem or Wi-Fi router. But you can get pretty cheap UPSs for about $50 or so, and I'm going to show you some of them a little later. So that's what you want to put. Now the question is, we're going back to how much power do I need when the power goes out? So the first thing is you want to start looking at all of your equipment. So here, for example, this is a charger for a laptop and or power adapter for a laptop. It does charge the internal battery. And what you want to look at is you see that it's a 65 watt charger. So you can assume that this charger is 65 watts. If you have these numbers here, I would even rely on these numbers better. This says that it takes about 100 to 240 volts at 1.8 amps. Notice that even at 1.8 amps at 100 volts, we're talking about, if I multiply them, 100 volts times 1.8 amps, that gives me the wattage. I'm going to get 180 watts and not 65. And the reason for that is because this power adapter is not 100% efficient. But, you know, even if you look at 65 watt and you calculate some efficiency or put some efficiency, now you know that this device requires 65 watts. You can find labels on every piece of equipment. So, for example, this is a 32-inch TV, and you can see that it requires 135 watts. This is a Samsung screen. It's a 22-inch monitor, and what I found here is that it takes 100 to 240 volts at 0.5 amps. So I can assume at 100 that we're looking at about 50 watt, maybe 60 watts, something like that. So you can find those levels and then start adding up how much current, how much power or wattage do you really need. So for a typical setup, you can see that I have here the 40 to 130 watt for the laptop. So a gaming laptop, a higher power laptop would be on 130. Mine is 130 watt. Some of the smaller laptops could be about 40 watt that they require to stay in operation. Extra screens, if you need some extra screens, that would be around 60 to 100 watt each. Lighting, if you have LED lighting like I do, that would be between 40 to 100 watt, maybe even less than 40, especially for a smaller studio. You have the camera, which I would always recommend the camera not to operate on its own battery, but rather use a charger that's always connected, and I have that. That's about 20 to 30 watts. That gives you a total of 160 to about 360 watt. Maybe a little more if you have more screens, but this is, you need to calculate this. One thing also to keep in mind is that when power goes out and you know that you're running on UPS and you know that the more power you're going to consume, the faster you're going to run out of the battery inside of the UPS and power would go out, that you may, if you know that you lost power, you may want to turn some of the equipment off and just say, you know, I'm going to be operating at a smaller setup. Again, don't forget the modem or the router or multiple of them. So I have two modems, I have two Wi-Fi routers, and I have a load balancing router in between them. So my setup probably is about 150 watt, maybe to even 200 watts at that station over there. And yes, I do have two UPSs. So how do you choose the UPS? Well, two of the leading companies are CyberPower and APC in producing and selling UPSs. And so I took one of them, CyberPower, for example. On their website, you can actually find this tool. And if this is one of my UPSs, what you will see is you will determine, you can actually move the cursor up here. I'm not showing you the live website, that's just a screenshot. But you will see that for this UPS, if you assume that you need 200 watts, it'll take you just about 36 minutes. It would keep you running for 36 minutes. If you're going to require lower power, like let's say 100 watts, you can see that you're going to be probably around 80 minutes here, and so it's going to run for longer. So again, that's a trade-off. And of course, if you want to run all of the possible equipment and load it up, you can find yourself with enough power for about 10 minutes. Same thing with APC. APC has something that would help you determine which UPS you should get. So you can say, I need this amount, I need 500 watts. I'm operating at 120 volts. Then you're just going to say, I need it for 1 hour. And it's going to tell you what UPS is going to be the best one for it. Here is another device that I found. It's sometimes they call it power stations instead of UPS. One thing I want you to notice, and it says 288 watt hour. So again, if you have 288 watts to load, then you know it's going to run for about an hour. But notice that it says 288 watt hour battery. So it really, instead of just saying that this device has 288, it says something about the battery, and I'll get back to it. It does say something about pure sine wave, and pure sine wave is a clean power signal that if it goes, some of the devices would really feel bad if what they have is not pure sine wave. So that might be something you want to look at, but I'll get back to that again. As I said, they focused on the battery, and really the battery inside of those devices, inside of those UPSs, there is a battery. And the battery is what determines how long it's going to run. So let's take a look at a battery. This is kind of a pretty standard battery that you're going to find in a UPS. This is what they look like. You may have seen them the same, very similar in an alarm system. And what I want you to notice is that those batteries are typically 12 volts. And there's something here that says 9 ampere hour. 9 ampere hour. So it can deliver 9 amps for 1 hour. And this may not say anything to you right now, but when you do the calculation, which I'm taking you through right now, you'll see why it does make sense. So first of all, you want to make sure that the UPS that you're buying can provide enough power with some extra. So if you have 250 watts that you know you need supported, you don't want a UPS that can only support 200 watts. I would probably go with 500 and above. However, you're going to see that there is also a correlation to the battery size inside. So now it's down to the battery. And the battery is the battery that this UPS can support. It's not like you can choose the different battery that this UPS cannot work with, because the UPS may not be able to charge this battery. So you want to make sure that the UPS can support the battery and whatever battery is inside, and just go to the data sheet or the specifications of this UPS to see what battery is inside. Most batteries are typically 12 volts, as you saw from this battery here. It is a 12 volt battery. And so take the power that you need and divide it by this 12 volts. So if, for example, I rounded it to 240 watts, if, for example, you need 240 watts, divided by 12, you get 20 amps. You need a total of 20 amps out of that battery to operate your equipment. Now the question is, how many ampere hour can this battery provide? And if this battery, for example, was a 9 ampere hour battery, take the 9 ampere hour divided by the 20 amps that you get, and what you get is that this battery will carry you for 27 minutes. You may want to take some spare, so assume you can reliably count on 20 minutes in this battery. There are bigger batteries. So for example, take this battery. This is a 100 ampere hour, 100 ampere hour battery. That's pretty powerful. The only thing is, before you jump and get a battery like this to put in your UPS may not be able to support this battery. So there is a good relationship between the UPS and the battery itself. So if I move on, and the setting that I'm showing you right now is we're going to have, and the setting that I showed you before, this is like almost the complete picture. This is what I currently have right before what I'm about to add, and you'll see what I'm adding here. This is my computer, camera, microphone, lights. This is what exists in my home office. My home office is powered by a UPS. This UPS can carry what I have here, including the charger for my cell phone. It can carry it for just about an hour. The battery inside here is a battery that's big enough. I believe I have a 20 ampere hour battery inside of this UPS, and therefore, and it's a $150 UPS, just so that you know, and you actually saw the picture of that UPS before. That's the CyberPower one, the 1500 CyberPower. And so it can carry everything here. I can connect through Wi-Fi to my cell phone that will run off of the internet, but I have a second UPS, a slightly smaller UPS, because I have less power requirements to power the modems and the Wi-Fi router. So if power goes out here, my modems are still running, my Wi-Fi router is still running, all of my equipment is still running based on two UPS devices. Let's add another layer. And for me, I'm a little concerned that if I'm running a full day workshop, I mean, people have dedicated a full day to spend with me, and I've done quite a few of that since the pandemic started. I don't want to tell them that I have enough power for 1 hour. So what I would want to do is I would want to add something that's called an inverter/charger. So make sure it's not just an inverter and definitely not just a charger, but a device that's both an inverter and charger. And I'm going to show you the one that I'm getting in the next slide. That's actually running off a car battery. And a car battery is going to have a lot more power than a regular battery. And it will, so if we're talking about a 100 ampere hour car battery, this is going to last me for a day. Okay, so the device looks like this. Again, the one I'm looking at is $467. Notice that it does not say pure sine wave. This is another one. You can see that it's more expensive. It is a little more powerful. I mean, the one that I have here is $1,250, which is good enough. This one has 3,000, so that's a lot more. So the higher price is due to that as well. But this one generates pure sine wave. Now, I don't care that much for pure sine wave for a simple reason. Whatever comes out of the inverter charger goes into the UPSs themselves, and they are not so sensitive to how clean the power coming into them is. So this one is good enough for me. This is the one that I ended up choosing, and I'm getting that one alongside with a battery. And as I said, there's this alternative as well. There's one more alternative, of course, and that's to actually have a portable generator. There are different types of generators. Rarely a generator would generate clean signal, but again, if you feed that into a UPS, then that's not a big deal. Different sizes of generators. I clicked on this one, but it looks like they have less smaller generators, which probably cost less. I didn't look at them. They're generators that run by fuel, gasoline, regular gasoline. They're generators that run by propane tanks, and there are generators that run by natural gas that you can feed from your home. The advantage of those ones are that there's a continuous flow of gas into them. The final thing that I want to say is make a checklist. If something is happening, if you're going to lose power and there's anything that you need to do, you're already under stress when that happens. And what I would recommend is that you make a checklist of what happens if power went out. If you got an indication, maybe the room lights are going to go out, even though your current light, your LED light is staying on. Why? Because it is on a UPS. If you know that there are certain things that you need to do, for example, one of the things that I'm going to want to do is the inverter and charger is in the garage. It's always going to stay there, and it's not going to be on all the time except charging the battery. When something happens, what I will do is I will keep on going because my current UPS can carry me for about an hour. I'm going to take a 5-minute break. Nobody's even going to know. When I go to the garage, I run my cable back here and I power my UPS, both my UPS devices, off of the inverter and off of a car battery that will last for a full day. So just make yourself a checklist. If power went out, this is just like emergency checklist in airplanes. You have the regular checklist, takeoff, climb, I don't know, cruise, whatever, descend and landing, but you also have emergency checklist. And I feel very comfortable when I have a checklist for any emergency. I will just open to the right checklist. I have it in a binder and just follow what's there. Don't have to worry about the stress of what happened, the power just went out or internet just went out, which I addressed on another one. Again, I hope this is helpful. Ask questions if there are any questions. And as you could see from previous videos, whenever I have the time, I'll shoot another video, post it so that you can get your questions answered. Once again, I'm Yoram. Be good, be safe, be trusted.